So a very good evening and warm welcome to the first technical session of NDE 2020 post the plenary lectures and of course the memorial lectures which we just finished a couple of minutes ago. So welcome to this particular session, which is titled NDE 4.0 Awareness, Relevance and Adoption by Industry. We have 5 excellent speakers and 5 excellent topics which we are going to be covering in this particular session. And it is now my pleasure to start introducing the speakers. So the first 2 talks is about the what, why, and how of NDE 4.0. And for doing this session, we have 2 eminent speakers, Ripi Singh and Johannes Vrana. Ripi is from USA and Johannes is from Germany. So let me give you a very quick introduction of both of them. Dr. Ripi Singh is now a purposeful innovation coach with a lifetime of learning in technology, people, and process development. Started all with Aging Airplane Program in 1992 as a postdoc fellow at Georgia Tech. Decades of his research work on fatigue and fracture, damage tolerance, human factors in NDE is well published and frequently referred to. Ripi is now working hard to bring Industry 4.0 perspective and innovation process to the NDE community and the city ecosystem with his virtual coaching lectures and articles. Ripi serves on various university advisory boards, US delegation to TC 279 on innovation management, and City Academy of Science and Engineering. Ripi is an author of 4 books, which were just released about 2 weeks ago, and over 100 peer-reviewed publications and dozens of keynote lectures. I will also introduce the other speaker, Johannes, because they're going to be doing this session together. Dr. Johannes Vrana, born in 78, studied physics at the Technical University of Munich, Germany, completed his diploma thesis in 2004 on atom-photon entanglement at the chair of Theodor Hansch, and his PhD in 2008 on thermographic testing at the University of Saarland. He then worked for Siemens Power and Gas in Orlando, USA, as well as in Berlin and Munich, Germany, and was chairman of the Siemens NDE Council. In addition, he was responsible for the development of automated NDT and SAF. In 2015, he started his own company, Vrana GmbH, in Rimstick, Germany, which specializes in NDE consulting and solutions, R&D, training, and software development. Moreover, he is chairman of the ISNT Specialist International Group on NDE 4.0 and of the ISNT German section, and of course the German Society for NDT subcommittees on interfaces and documentation for NDE 4.0 and automated ultrasonic testing. Also the editor for NDE 4.0 for the Journal of NDE. With this brief introduction, the floor is entirely yours, Ripi and Johannes.
Thank you, Shyam Sundar. Good evening, India. How's everybody doing this fine evening? While we are wrapping up the year 2020 with all the ups and downs that we have seen so far, let's pray for a fantastic 2021, which will start in about 3 weeks. Okay, so just before this, Shyam Sundar mentioned that this is the real first technical session, and it's kind of an honor and pride and joy, and I'm really excited to open this session here today on a topic of NDE 4.0, which we are all so very anxious to see how it unfolds and what does it bring for the NDT community, for the manufacturing community, for the asset service providers, for everybody around who gets excited about, here's technology, here's automation, here's artificial intelligence, all the buzzwords that come together under this big umbrella. My desire today, along with Johannes, is to share with you what Johannes and I have learned in about 3 years of our journey around bringing Industry 4.0 digital technologies into the NDE domain. Okay, and that's what we call as NDE 4.0. That's what we want to do. Instead of us talking separately, we're going to tag team. I will talk why, then Johannes will talk about what, then I'll come back to how, and we will field your questions together after both of us are kind of done sharing our content and learnings with you. So as I was mentioning to you how our journey started, Johannes started in this sometime 2016, 2017 in Germany. I got into this in 2018 in the US. And we joined hands fairly early, around spring timeframe, 2.5 years ago. Since then, we've been running common conferences, common sessions, various panels at all of the ISNT conferences. About 9 months ago, we started engaging a much broader global technology community to actually look at NDE 4 as an ecosystem. And this community is now aiming to bring across the entire global entity fraternity, so to say, is some kind of a guidance on how to go through this transformation. So there are a lot of people who have come to help us in developing what we would call as a roadmap guidance across everybody that we can use on adopting NDE 4.0. I'm not going to name 20 different people, but that's just an example of how we come together. And in fact, I would say COVID helped us get closer because we were able to have more frequent meetings, engage a lot of people from around the world, and really resolve and address some of the concerns, issues, questions we all come across on this topic. So, you will get to hear a lot more about this next year, April, when we roll out the guidance around NDE 4.0. For now, a brief primer. What is Industry 4.0? What are the 4 industrial revolutions? I think most of you know about it. I'll just quickly recap. The first one was around mechanization, powered by steam. Second one truly was the factory environment powered by electricity, mass production. Third happened because of the computers. And a lot of us who are attending this conference grew up during the third revolution. The computers were just beginning to enter India and our work life domain. We saw the third revolution unfold in front of us. And now we are at the cusp of the fourth revolution, which is powered by connectivity, which is powered by bringing the mechanical, the physical systems that we learned in Industry 2.0 with the digital systems that we learned during Industry 3.0. So now it's the confluence of those two. And that's what's the big thing about Industry 4.0. What does it mean to the inspection sector? In the inspection world, Johannes and I collectively have shaken this thing over the last 3 years with input from many people. The revolutions don't necessarily tie with the same timeline as the industrial revolutions, but they pretty much go with 4 different major changes that we have seen, starting with the first one. Long ago, it was all based about human senses, vision, hearing, touch, smell, stuff like that. Then came procedures where you could amplify human senses, but still you were looking at it at the surface of an artifact. The second revolution in NDE happened when we developed a way to look beyond the line of sight, beyond the surface. We could go deeper into it. And third happened when we learned how to handle all of that data in a digital form. And now we are talking the fourth one, which is about connecting all of the physical inspection systems with a digital way of managing it. So today's talk between Johannes and I, like we have mentioned a couple of times before, it's about why, what, and how. So let's start with the why. Why do we need this? Is this about digital? Is this about transformation? Or is this about eventually serving a purpose that we would like to accomplish? The why of NDE 4.0 comes from the why of NDE and the why of Industry 4.0, because we are putting these two things together. So at least it's got to address those two, plus whatever benefits we get because of synergy. We'll share with you that as well. Why do we do NDE? We want to improve safety of the products. We don't want accidents of this type. 30 years ago, when I first got into damage tolerance aging aircraft, the most popular picture was the Aloha accident where Boeing 737 top was ripped up. Right? That's become so old and so used, we've become bored of it. Now, this is a newer one that we use to trigger a need for safety. But why Industry 4.0? When Germans gave the concept of Industry 4.0, Japanese said, technology for the sake of technology is good, but technology ought to serve the purpose in terms of quality of life. So anything that we do, like artificial intelligence or augmented reality or 3D printing or IoT connecting devices, it should eventually improve the quality of life. It should make mobility smarter, energy renewable and smarter, healthcare smarter, food, housing, cities. In India, we talk about 100 smart cities. I mean, that's the purpose of Industry 4.0, to bring value to social cause, to workplace, to health. So if I were to copy the same style and learn similar things, I should be thinking of on very similar lines. What is Japanese definition of societal generations? They talk about, the first one was hunting-gathering society. The second one was we learned the agriculture piece. The third social revolution really was the one triggered by the first industrial revolution, right? And then the fourth social revolution happened because of the computers. And now, if we are at the cusp of Industry 4.0, then we are also at the cusp of a revolution in society. So they define it as a society 5.0, where you derive economic development along with social solutions. Some of the prior revolutions, the true industrial revolution that happened in 1700s, it brought significant health concerns. And those health concerns have actually elevated with every revolution, including the computers. They brought a different class of challenges to the society, the digital divide, the psychological challenges we got because of the computers coming in. So the whole idea now should be, if we really want to adopt technologies, we ought to do it in a manner that brings value to the society in addition to pure economic values. Don't just drive technology for the sake of making money, but drive technology for social solutions as well as economic development. So if I copy the same thing, I could say, if Industry 4.0 is here to serve Society 5.0, bring social solutions and economic development, the NDE 4.0 should serve something I would call Society 5.0, which is safety solutions as well as economic value. This means shift the concept of NDE from a cost-centered burden to a value-generating activity, where people want NDE, where service providers, where asset owners, airlines, railways, plant guys, the original equipment manufacturers, they want to see NDE. They depend upon NDE to generate the valuable data that they would need to further improve the product, further improve the reliability, the safety, and everything. So that's the purpose of NDE 4.0. Blend safety solutions with economic value. And safety solutions both by keeping inspectors safe. I have seen inspectors go into plants, into uncomfortable environments, going under the bridges, cold weather. There is a risk that inspector takes in many circumstances. Want to reduce that. There is a risk that comes because an inspector missed something. I want to reduce that. So both from asset user as well as inspector safety is important. And economic value, lifetime of the asset that we are maintaining, plus also taking that data to improve the product design. So there are multiple use cases that come out of this. What's the promise in terms of safety assurance? So, I grew up in the damage tolerance world, and I used to study factor of safety and safe life and fail safe as philosophies for assuring safety. And I spent, I think, 15, 20 years doing damage tolerance analysis, all based on NDE, POD, risk assessment, and looking at SHM and predictive maintenance. NDE 4.0 has the power to take us from predictive maintenance to prescriptive handling, prescriptive maintenance, prescriptive inspection, where you can handle individual asset. You can prescribe what each airplane, what each train, what each plant system needs at what time. Take for an example. Okay. You have an aircraft, you created a digital twin for that asset. You use technologies like 5G to capture NDE data. And I will use the term relevant data rather than big data. And you also pull the data from your digital manufacturing, the previous in-service inspections. You combine that data, you simulate, you predict what can happen to this specific asset, this particular aircraft tail number. You can study the damage progression, deploy your AI algorithms, visualize it through augmented reality, and then go back and prescribe how you will handle that specific asset. That's what we mean by prescriptive maintenance of individual assets. That's the revolution that NDE 4 can bring. It can combine the physical world with the cyber world, keeping human in the loop still. I'm not ready for 100% automation, still keeping human in the loop. So that's the promise of NDE 4.0. It can bring safety, quality, speed, cost advantage, all of them together. You know, up until now, whenever we do projects or whatever, you can choose two. The third one comes out. But for the next 5 to 10 years, while we are going through this revolution, you do have an opportunity to do all three with NDE 4.0. Once it stabilizes, then again, we'll be at a point, okay, you can only choose one or two. Plus, remember, as we extend life of the asset, we reduce the waste, we reduce the garbage, we reduce stockpiles. There's opportunity for sustainability. And as we go more connected worldwide, we have an opportunity to also build business resiliency. So there are other reasons that NDE 4 can actually bring value. Johannes and I have debated and compiled 10 different use cases or value propositions for bringing NDE and Industry 4.0 together. If you take Industry 4.0 digital technologies into NDE, you can think of NDE capability and reliability, improving efficiency, effectiveness, improving NDE equipment, improving inspector safety. And if you take NDE data back into the Industry 4.0, you can get into quality assurance of factory infrastructure, 3D printed parts, drones and critical industrial robots. We are not talking about it because that technology seems to get obsolete before it ages. But I won't be surprised if 5 years from now, one of those delivery drones is bringing a package for you and crashes in your backyard because of some reason, because we didn't realize how many fatigue cycles it had accumulated. And there was no regulation around inspection of delivery drones. So that's a use case that is yet to emerge. I hope we will learn before we have an accident. We can also use NDE data for continuous product design improvement. And of course, a new business model around data monetization can emerge out of that. So these are the bunch of use cases that further define why NDE 4 is a driver for us to think of. So purpose of NDE 4.0, safer, cheaper, faster. That's what we want to do. Safety and economic value is the reason why we should go for NDE 4.0. Now let's talk about what does it entail. And here I will hand over the screen to Johannes to continue with what, and then I'll come back to share with you the how piece. Johannes, on to you.
Now let's get into the what of NDE 4.0. But before we get really into the details of the what part, let's get into one word, which plays kind of a central role in this whole fourth generation, and actually our whole society as we have it nowadays. And that is the word digital. And there are two different verbs to that one, digitization and digitalization. Now, in most languages around the globe, including German, including Spanish, including Japanese, digitization and digitalization, they have no difference. This is one word, actually. In English, in the English language, we have two different meanings to that word. And for me, the difference between those two meanings is quite essential. Because digitization is just the conversion of an analog information into digital information. So if I take a sheet of paper and put it onto my scanner and make a PDF out of it, that's digitization. If I send an email, that's digitization. Now, you know, if you scan the document and you have a PDF which you created out of it, you cannot really use that data for something really useful. So, and that's where, this is why I say it's really important, because digitization is something which is the core of the third revolution. Where we are getting closer to the fourth revolution is once we're getting into digitalization. Digitalization is now making processes digital. So, for example, not anymore sending you an email, please do the inspection of, but you have a system on your tablet, let's say. Somebody sends that system a message. You should be doing an inspection on component XY. You go with your tablet to that component. You scan the barcode of the component. The system knows that you will be inspecting it. It shows you automatically the procedures, the standards you have to follow. It shows you the dimensions. It already perhaps does the parameters of your ultrasonic instrument. You start inspecting it. You do a couple of screenshots in between the inspection. Those screenshots are automatically stored back into the system. You enter everything you found in a digital way back into that system, and all of that data is then finally transferred back to a central database system. That is what we call digitalization. And that is clearly a completely different world than digitization. So you see where this third revolution is leading us to in the fourth revolution. Now, digitalization is where I say this is where we are on the way actually to the fourth revolution. Once we really reach digital transformation, then we actually get into, okay, now we are in the fourth revolution. Now, what is digital transformation? So let's say you do your inspection, and all that data you accumulate is then put into a database, which is then combined with, let's say, the financial data out of an enterprise resource planning system or some other data out of production, then put into a central AI solution, which is running on a cloud, which is actually doing a big data processing of all the data within your factory, so that finally this can lead to an improvement of the production and so on. So you see how many components are getting combined within this digital transformation. And that is one of the key components, digitalization. This is something you can do in your own factory. This is something perhaps you can buy. But once we get to digital transformation, even the big players, even the Amazon, Google, Microsoft, or IBMs cannot do such a digital transformation on themselves. This is the point where we are getting into a world of collaboration and where we need open standards. And that's when we really reach that fourth revolution, and that virtual physical loop Ripi was speaking about. But let's get a couple of steps back. Let's get to the first use cases, which are really obvious for NDE. And this is using the emerging technologies to enhance NDE. It's the use of virtual reality to help you do the interpretation of your results. So by, for example, showing you in some virtual glasses, not only the results of your ultrasonic inspection, but perhaps also some of the results from earlier inspection, some help on how to operate the ultrasonic instrument. So combining all of that information in one visual display. Or if you want to show the results to somebody who doesn't understand NDE, you can kind of project the results on that component to show it to somebody else, and they will immediately get what the situation is. So it will help with explaining NDE results. Now, coming to artificial intelligence. With all the different methods of artificial intelligence, we can clearly improve our signal detection, our post-processing, our defect finding, our defect sizing, defect characterization, all of those jobs we have. Not necessarily as something autonomous which does it and we do not see it. But for sure as something which helps the inspector to make the right decision. Robotics and drones, 5G for the communication within your factory environment, so that you have the possibility to connect thousands and thousands of devices within your own environment. And 5G is not just the faster internet. No, it's also something, 5G you can also use to establish a network within your own factory, which is sealed from the normal wireless connection network, and where you can connect all of those devices you have in your production. Additive manufacturing, blockchains for actually enabling us to do some, to making sure that the component you're inspecting is actually the component you were supposed to be inspecting, and so on and so on. So those are, for me, those obvious use cases, those use cases using the emerging technologies to enhance our NDE methods. And this is what I call Industry 4.0 for NDE. Now there are, Ripi already showed it before, those use cases, but there are 3 more to this category. One is being inspection support. So especially nowadays, with us not being possible to go to certain inspection locations. Let's say you have to go to Argentina to do an inspection job, something you cannot do currently. So you use somebody to do the inspection in Argentina, perhaps not the most experienced inspector on that component, but you can have this remote connection to the inspector, making sure that the inspector gets all the information he needs to do an appropriate inspection. We can use also something like a feedback from your from your NDE equipment, from your NDE hardware, from your NDE software, back to the manufacturer of that equipment. That helps actually the manufacturer to improve his system, which finally helps you to do a better inspection because you have better inspection equipment. And then we have all of what I call inspection control 4.0, meaning establishing digital workflows for NDE, digital commissioning, digital supply chain processor. If your X-ray detector breaks, the system automatically detects it and orders a new one. Or on the other hand, you're getting into a contract with a customer who wants you to do an inspection. Then this communication between you and your customer is done in an electronic way. And by electronic, I mean not using actually email. I mean digitalization. Component traceability, life cycle records, performance statistics. So you see, this group of use cases, Industry 4.0 already will be making our lives as NDE professionals a lot easier, a lot better. But there is a second part to it. And a couple of months ago, I actually did a survey on social media, and I asked people for comments on, okay, what have you heard on negative thoughts about NDE? And I got about, I think it was about 30 answers. And one of them, I didn't agree with that one, but I think it helps us to show us where we need actually improvement. And it's this one. NDT does not have any value at all. It only sorts out parts that in reality are good. I don't want it. I would never ever do it, but my customer insists on it. I would prefer spending the money into further improvement of my production. So this customer sees no value in NDT, sees NDT as non-value added. And he doesn't want to do it. He just sees it as a waste of money. But he also gives us what he really wants. He wants to improve his production. What he doesn't understand, that if he would take all of the data from NDE, put it into a database, and run a lot of statistics on it, he would actually be able to improve his production by analyzing the results. So, but what does this customer and most of our customers and most of us do with all the NDE results? We put them in archives. Or we take all of the reports we are generating, we put them on our scanner, and we're making a PDF out of it. We are digitizing them. But what we need to get to digitalization, also here, to the digital transformation. We need to become a data source for Industry 4.0. NDE is giving the customers a look into the components, is identifying material inhomogeneities, material structures, a lot of data of the internal structure of the component. But the customers are just using all of this data to use it for quality assurance, to use it as a go, no-go decision. But by using actually all of the data we have, putting it into the central database systems and combining it with sensor data, with financial data, with all other data, we're coming to a completely different story. And this, for me, is the second big group of use cases, and I call this one NDE for Industry 4.0. So how do we get there? Now, if we want to talk about industrial Internet of Things, we have to talk about, okay, what is the as-is situation? And in current production, the as-is situation is normally described by this automation pyramid. This automation pyramid is clearly out of the third revolution. And what we have all the way on top, we have the enterprise resource planning, which does the planning of the whole production for the whole enterprise, including the financial data, including all the contracts with suppliers and customers and so on. This information, this planning from the ERP system is then brought down to the MES system, SCADA, PLC, until we reach the production floor. And finally, the data accumulated during production is then condensed back into the ERP system. Okay, so what do we need for such a pyramid? We need a lot of interfaces. And there are two major setbacks in this model. And the setback number one is between the PLC and the SCADA level. Because what we actually have, we have thousands and thousands of those PLCs. And they are all produced by individual OEMs, and each of those OEMs has its own proprietary interface. So actually, to be able to combine all of those PLCs into the SCADA system, we need thousands to implement thousands of interfaces, and that for every single manufacturer, because every manufacturer has different devices. And our NDE equipment actually belongs into this category of PLCs. So you can see why I do not really like that much all those proprietary interfaces we have. And this is also why most of our NDE systems, and actually also a lot of other systems in industrial production, are not connected upstream. They are just standalone systems. But there is a second big issue here, and that's between the MES and the SCADA system. And actually that one is bigger, because mostly what is done, MES systems and SCADA systems do not speak with each other. between those two systems, we have routing sheets. We have paper-based routing sheets. We plan the production in the ERP. It's broken down to the MES system. In a lot of places, ERP and MES are actually in one system. And then they finally print a routing sheet, a traveling sheet, which goes with the component from one place to the next. And then this information out of that routing sheet, of that paper-based routing sheet, somebody sits in front of his computer and puts all that information back into the SCADA system. This is current digital production, third revolution. Now you can imagine if the downstream is already implementing paper, you can imagine what happens with combining all the data upstream. Number one, we do not get even from PLC to SCADA, but once we reach SCADA, what we actually do, we print all of those reports, we scan them, and we put them as a scanned PDF into the MES system. So kind of the information is lost once it's getting into the MES system. Now, there's another issue with that pyramid. This pyramid just deals with industrial production. But we do not actually start with industrial production. We start with design. So we start perhaps with some computer-aided design. And the design software is actually not connected to our automation pyramid. Yes, in some cases we have a weak link, and that weak link means in the ERP system we store which file we have to access in the CAD system so that we can access it. And perhaps the final design out of the CAD is then converted into a PDF and then stored in an ERP system. But that's all. That's all the connection we have. Actually, it would be good that we have the CAD directly connected to the automation stack to automatically program the PLCs, which are actually doing the production, and so on. Then we have a lot of production actually running at our suppliers. So, and all the information which is gathered during the production at the suppliers, we put some scanned PDFs back into the ERP system. So again, a very weak link. Now we are coming, okay, now we have finished our production and we are running the product, or somebody's running the product. So we're getting into product lifecycle management or maintenance. And all of that data, there is no feedback loop into the automation stack. That's all, if we want to do it, it's all handwork. Same if we go to structural health monitoring, and for sure, if we have digital twin and thread or a cloud, most of them are kind of separate. So what do we need? And this is now really the idea of the fourth revolution of the industrial Internet of Things, actually of the Internet of Things, is to get rid of all of those proprietary links of the automation stack and actually to use open interfaces so that everything can connect to everything else. And not only in production, in design, in maintenance, going all the way to the end of life, going to the supply chain, going to everybody actually, which is kind of connected to one central asset. Now, where do we find NDE in here? Now, number one, structural health monitoring is NDE. We do a lot of NDE in production, we do a lot of NDE in maintenance, and we do a lot of NDE at our suppliers. But what do we do with all of those NDE results? We put them on archives. And this is why the whole NDE community has to change. We as an NDE community have to become a core part of the industrial Internet of Things. And the big players are working on the industrial Internet of Things. It's not something which is not working. No, the IIoT is out there. It's working. But we as an NDE community are not within the IIoT. But we have to get there. We have to become a central role. And once we get there, then actually people will also see that NDE is actually a valuable data source which they can use to improve their production, to improve their design, and to improve also their maintenance. So, but how do we get there? Now, what we need to give data structure, to make data machine readable. So not anymore paper-based data recordings and scanning them. We have to convert data into information. But how do we get to that point? Now, on the next slide, I will show you a number. Every number is some kind of a data. And if I show you that data, you will immediately know, most likely, what this information means. But if I enter that number into a computer, the computer will have no clue. It will just be an integer we are storing. I guess you all know what this number means. But for a computer, the computer doesn't know, is this the length of a truck? Or is this the gain of a UT instrument? Was it before or after calibration? At which day, which probe, which components? So we have to see, number one, the unit of measurement for such an information or for such a data point. And we have to see, okay, how is this information connected? We need all of those connections between all those different points of information. And once we give a computer that understanding, and this is something we do with semantic interoperability or by using ontologies, then the computer will understand that this is actually the answer to the ultimate question of life, the universe, and everything. At least according to Douglas Adams and his book, Hitchhiker's Guide to the Galaxy. So now we have semantic interoperability. Semantic interoperability helps us to convert data into information. It helps us make it machine readable. It also helps us to combine this information with the information of any other data source, for example, some sensors. Now comes the point, okay, now we have to communicate that information. And there are a couple of so-called core connectivity standards out there. And those are the 4 ones which are actually discussed by the so-called Industrial Internet Consortium. There is one which is called DDS, which is really for high-speed, low jitter, low latency communication, but it doesn't have semantic interoperability. So in my eyes, I really do not see the big point why we actually see this standard in here. The other 3, different story. 1M2M. 1M2M is coming from telecommunications. So it's really good for mobile applications. And we have, with the so-called 1M2M base ontology, we have a good semantic interoperability. They still need to do a lot of work to get there, but they are on the way. Web services, this is now coming from the World Wide Web Consortium, W3C, which also defined our internet as we are used to use it, www. And it's mostly for human user interaction, but it can also be used for computer-computer interaction. And with the web ontology language, we also have a pretty good semantic interoperability. And finally, we have OPC UA. Now, OPC UA, this is coming from the manufacturing environment. it's actually a framework of interfaces. It's client server, pub sub, all kind of other things. It's TCP IP, it's UDP, whatever you can imagine you can do with this interface. And we have a very strong semantic interoperability by those companion specifications. It's actually a national standard in China and in Korea. And if you talk to the people dealing with Industry 4.0, actually OPCUA is kind of the standard they think will be the standard for Industry 4.0, at least for a lot of applications. And this is why actually the German Society for Non-Destructive Testing has decided to create a companion specification for non-destructive testing. We're just in the beginning right now, but I hope that once we come to next year's conference, we will be able to actually show you already the first implementation of such a companion specification so that this can actually be used all around the globe. Now there comes one key point. What do we do about the big files we have in NDE? Yeah, there's another industry, medical. In medical, they also have, if you get into the hospital and some doctor puts your information into the computer, that information is actually transferred using a interface called HL7. But once you come then to get a radiography taken of you, so let's say a RT examination, then actually those results are stored in a different, with a different standard, and are communicated using a different standard. And that standard is called DICOM. DICOM stands for Digital difficult word. And it is not only, it's a, number one, it's a format to store data. And number two, it's a format for communication. And then we have a central server, the PACS server. All the results which are gathered during radiography are stored in a PACS server. Then actually the doctor analyzes the data, puts his report back into the PACS server, and this report is then finally put back into the other information systems so that everybody in the hospital can access that report. And we can imagine something similar actually for medical application, for NDE application, sorry. We could use OPCUA on the one side, and we could use DICONDI for everything which is concerned of all those big files. And also DICOM and DICONDI have a very strong semantic interoperability. It's actually, they completely defined in which field which information has to be stored. Now, we can use the semantic interoperability. We can use it for data formats. We can use it for the IoT. We can use it for interfaces, for cloud, for databases. We can also use this to automatically actually fill an AI, because information is a lot better for an AI because it knows finally how to do the interpretation of it. And we can also use it in digital twins. Now, what is a digital twin? Now, digital twin of myself, yeah, what I need for digital twin for myself is we need a lot of information. So for example, my financial data, my medical record, and so on. Then we put all of this information into some kind of analysis, some kind of simulation. And finally, we put it into some kind of visualization, so to gain knowledge. So the key task of a digital twin is to transfer information into knowledge. And those three here And actually also our governments and also our health insurance. Yeah, they know how valuable data is. They know how valuable information is. That's why they like to gather all that information, so that at some point they can use that information, run it through some analytics, visualize the data, and learn a lot about you. So that, for example, Amazon can actually show you the things you really want to buy. Now, digital twin can be about a person, but for sure, it can also be about an inspection system. And what we can see here is actually here, this inner box here. This is representing actually the original real component or real system. And that blue box around it, this is actually representing the digital twin. We can also have a digital twin of a production line, digital twin of an inspection equipment. So you can see we can do kind of a nesting. So we have the production line on top. Underneath the digital twin of the production line, we have all the digital twins of all the different machining and manufacturing devices, including inspection. Underneath inspection, we have the inspection equipment, the mechanics, and so on. We can also have it for detectors, probes, sensors, for your software, and also for your inspector. Now, if we think about those digital twins are all related to some equipment to produce something, including the inspector or including the man who's actually working on a machine. But there is a different kind of digital twin. So this is all equipment related, but there are also ones which are product related. So with a product, we start with an initial idea. We get to a design phase. We produce raw material. We get into individual components. We finally get into a finalized product, which is doing some operation until we finally get to a point where we get to an end of life. So now, how do those digital twins play together? Number one, we already said we have the production line on top, and then we have kind of this tree or this pyramid of this nesting structure we have within the industrial production. And on the other hand, we have the product we are producing then kind of on a vertical line. And at some point, we are doing with our inspection system the inspection of the component. Now, this horizontal line, this is also called the digital thread. And the vertical line, this is called nesting. And if we just look on the digital thread, actually, the initial idea and the initial design, this is actually done for a type of a product. And then once we get into the fabrication and the production, then we are actually talking about multiple instances we are producing of a certain asset. Now, all of those different kinds of digital twins we have, all of them have three key components. We start with information, we continue with simulation or some analysis, and we get to visualization. Where do we get the information from? We get it from all kinds of databases. We get it out of cloud. We get it out of the IoT. And information is data with semantic interoperability and with some reliability information. Even if I want to take some financial data into consideration in a digital twin, yeah, I need to know how reliable that information about the financial situation is. And the same goes for NDE. If I want to use NDE data in a digital twin, I need to know the reliability of that data. Then we get to simulation. By using normal algorithms, by using augmented reality, by artificial intelligence, by using quantum computers and whatever, we can do training, we can do predictive and prescriptive maintenance, we can do probabilistic life and behavioral analytics, however they are called. This is all the core part really of the digital twin, which is actually helping us to gain knowledge, which we finally gain by visualizing that data, by using a dashboard or augmented reality. And best of it, all in real time. Now, as I'm running a little bit out of time, let me skip the next slides and directly go to this one here, because this here really shows a little bit the loop we are talking about. So we are coming from NDE, we are converting actually that data into information using semantic interoperability. We're putting it into the IoT, combining it with all other data, putting it into one or several of our digital twins and threads, doing a lot of simulations, analysis on it, visualizing it, and gaining knowledge out of it. So we are using this circle, gaining data, converting it to information, converting it to knowledge, and this is the point where we can use the data to improve the production, the design, and the maintenance. And this will make NDE from coming from the point being an unnecessary cost factor to becoming one of the biggest data treasures for Industry 4.0. We already discussed about it. What we need is data transparency. We need open standards. We need semantic interoperability. We need data security. We need data sovereignty. And this is why the German society has actually created this Memorandum of Understanding for Data Transparency, which is co-authored actually by the Austrian Society, and also is actually all at the moment up with the Indian Society so that they can also put their logo on top. We also need reliability, and we talked about it already. And we need training. You all know the level 1, 2, 3 system. And there is a similar system actually for the data engineers, which are actually doing the implementation. But what we need is actually, we have to bring those two groups closer. And how do we bring them closer? Yeah, on the one hand, we need training for the NDE data engineers, or we need training for the data engineers so that they understand NDE. We need training for the NDE people to actually understand, have a core knowledge of all the IT and math. And we have we need the glue in between, NDE data scientists. This is kind of the path from the what of NDE 4.0 and the beginning on the path of, okay, how do we get on the way to NDE 4.0?
All right, so here we go now, back to understanding the how piece of it. Johannes shared with us what. It's a whole bunch of digital technologies that come together with the physical NDE that we shared earlier, okay? The portfolio of technologies, I think Johannes touched upon probably all of them in some fashion or the other, and this list keeps on expanding. I think it was 5 when I first started with the Industry 4.0, and then it was 9 when I got into NDE, and now it's 17, and next year maybe 25. So let it evolve, that's fine. We have all collectively, with the understanding of why, what, and why, what, and how, started proposing the definition of NDE 4.0. Okay, and it's again a draft, just take it with a grain of salt. The global community is looking at it, and we'll probably have a good one by April. It's about cyber physical NDE, including testing, which comes out of a confluence of Industry 4.0 digital technologies and the physical inspection methods, and possibly some business models to enhance inspection performance, integrity, decision-making for safety, sustainability, QA, as well as providing relevant data required to improve design, production, and sustenance. It's very long definition. We don't necessarily like it to be that long. We'll figure out a way to reduce it. But for now, it does cover every aspect that's touched in this talk between Johannes and I. Now, pursuing the digital technologies over here, we said, what are the principles that we could use with NDE 4.0? We looked up to Industry 4.0. We picked up their 4 principles around interoperability, decentralized decisions, information transparency, and technical assistance, and we translated them for the NDE. They actually map fairly well, one-to-one. You almost can change, from humans to inspectors, from devices to inspection equipment, and effectively use it as is. So that's what we are recommending. But the pursuit of this technology, like Johannes mentioned, requires a serious data exchange protocols, right? Data speed, bandwidth, the way we interpret data, the way we exchange, semantic interoperability, all that stuff that Johannes mentioned, that is very critical. If you learn from Industry 3.0, the internet came in late 60s, but it really became popular in the 90s when we all globally accepted HTML as a mechanism to exchange information. So something similar needs to happen over here, whether it is HL7 or OPC UA or whatever, wherever it goes. We're going to have to come to that, dump proprietary stuff, accept something that we can all universally exchange and connect. That will be an important piece for us to pursue this technology. When you come up with an idea for the technology and you want to implement, you need, as an organization, some kind of a process to make it work. A simplest thing that we talk about is you either have a strong customer insight, a pain point, or a need that somebody needs, or you start with an idea and find a need. Step 1 and 2 are kind of interchangeable. Sometimes you come up with an idea first, and then you look for a customer need. Sometimes you have a customer need first, and then you find an idea that solves that problem. But then you ask a question, value proposition. Does it make sense to the user? If the answer is no, you stop right there. If the answer is yes, you go to the next step and you say, can we do it in time and make it profitable? Does this concept even qualify? Is there a business case around this? And if it makes sense, go on. Otherwise, come back and revise. And then you actually run your traditional R&D project. So this value proposition concept qualification, they came out of a company called Strategizer, and they've got couple of beautiful books, which we have translated into other tools. And I will not go too deep into that because each one could take half an hour or so. I'm going to skip that, but I want to share with you that you start with hundreds of ideas and about 10, 20, 15, 30 will make sense to the user, but only 5 or 7 could make sense from business perspective. And only a few of them will actually bring value. The reason I'm emphasizing this process is one of the things that plagues most organizations is not willing to accept failure. We don't start a project until we can see the end and we can guarantee success and we can define ROI. We don't make an investment. And that is what holds us back from finding that 1 out of 10, 20 ideas that will actually work. When we are going through the industrial revolution, there is so much change. It is very hard to predict, very hard to plan what will work, what will not work. So having a process which is like gated, but even before you start a project, is the one that you need so that you can explore a lot and then exploit only what makes sense. And one of the things that I tell everybody in all my clients, leverage smartphones, leverage mobile devices to the extent possible. Avoid recreating what's already existing in a handheld thing. This is the wheel for the 4th industrial revolution. The mobile device is like a wheel. Don't reinvent it, use it as is. Just when the 4th industrial revolution started, ISO started asking the same question. Do we need a standard to help people develop technologies, go through innovation with lower risk? And there's a whole bunch of ISO standards, the 56,000 series that's coming out. I have had the privilege to be a part of this ISO development for the last 2 years, and I would like to see Indians participate in there. Every meeting I attend, I do not see. Please, anybody who's listening to me here, reach out to BIS and tell them we want to participate in ISO 56000 because we need it in India in every industry. And you guys can also use, you can use 56002. The core piece of 56002 is the same as what I just mentioned, a process to go from idea to a successful project. It's the same 5 steps. So, one way is pick up the thing that I've written. The other is pick up the ISO process, but please participate in ISO as a contributor also. Another important piece that we are going to face in Industry 4.0 is talent. We are going to be really starving of talent from 2 reasons. It needs new set of skills and it needs a new mindset. Johannes went into the detail to some extent. NDE skills and digital skills, and you have to think of the overlap of the two, the so-called NDE 4.0 skills, because this will be very heavy digital activity. I heard a statement from one of the Silicon Valley big shots saying, in future, every business is a tech business because it's a part of the 4th revolution. It has to have a digital component. You're thinking of digital twin. That's the way to go. So make sure that you have a way to invest in your employees, to invest in yourself, to learn about digital skills, to practice, and stay ahead of the game. And these things, unfortunately, the challenge is they change so very fast that if you think, 5 years from now, I will catch up, you may never be able to catch up. The train may be going too fast, too furious, too far ahead of you. There's one opportunity to leverage on the talent, and that is bringing more women into NDE. There are reasons why women will have advantage in the 4th revolution, and also bringing the change. I think the way women handle change is through collaboration and focusing on relationships, focusing on connections, and that's the fundamental thing we need. The 4th revolution and the NDE 4.0 is not just about technology connected, it's also about people connected to bring that change, to bring that digital transformation. Otherwise, it won't happen. The process I talked to you about, women are actually very strong in the first couple of steps, capturing customer insight and ideation, and men are strong in executing the project. So if you blend those two, you will actually be able to create new technologies and implement. And if women also participate in the leadership roles, you will be able to make that transformation relatively easier. And it's not just what we think or perceive. It's actually biologically proven that the brains are wired differently. And the left brain is logical, the right one is intuitive. We need both, and women have better cross connection as compared to men. This is a biological study. There are references published around this. The role of human being will change as we go into NDE 4.0, and that's going to create certain other psychological challenges that we will see. We have to watch out for new sources of error. It's not about human being making a mistake and setting up the equipment. Human may have made a mistake while programming the robot. There could be other issues around training that robot. Is it being trained by everybody, or are we having ISNT level 3s train them? You might even have a psychological difficulty tomorrow when robots become so strong that they become your boss. How would we feel receiving a job instruction from a robot? I don't know. It's an intelligent guy who understands much, who figures out something and has a gap in what he's doing, and he sends an instruction saying, hey, I want you to do this, blah, blah, blah. It will be very nerve-wracking to me when I get an email from the system, and I know it's not really why, they're not instructing me to do a certain job, but just think about where that could go. All of this invasion of AI into our life creates another class of problem, and that is ethics. And I want to spend 2 minutes on this topic because this is really important. Areas where the technology is developing faster than law can keep up with, and we have no precedence where we will learn it from, we have a real risk of walking into an uncertain domain of application where we don't know what the outcome would be. And if there are people who are taking business decision because it's a profitable thing to do, you can have side effects that we cannot live with. So it's a real challenge to, when we fall into this domain where the decision is being driven by money and legal risk, but there's no legal constraint because law has not caught up, and there is no history of how this will come out, it's a real challenge. You can ask some simple questions, but will that work? When you can ask a question, is it the right thing? Is it the right way to do it? Will it hurt anybody? Those are simple starter questions. If the answer is don't know, then take a pause and think of what you can do. You know, there's a big social media noise going on around Timnit Gebru, who was a ethics researcher at Google and was recently laid off. It's unfortunate, even when you raise flags around ethics and you figure out something, and then unethical action happens against you. So I don't know what the inside story is, but it's getting attention. The Markula Center of Applied Ethics at Santa Clara University has given 16 challenges with AI that we should think of. So again, another very well-reputed university with lots of documented stuff online. Refer to that. US Department of Defense has issued ethical guidance around how to apply AI. It's about some individual should be responsible. That individual should have the competency to do it, and we should be able to trace if something goes wrong. And a couple of things which resonate with me is that it should work on explicit, well-defined use cases, so I can rely on it. It should work within a certain box. And I should be able to govern it that it works within that box. If it steps out of that box, creating unintended consequence, we should be able to detect it and deactivate that system. So, you know, some of this guidance is very generic, but if we look at it and try and apply it to automation, to AI in NDE, we can actually apply them and use that as a guidance as we go through development and adoption of NDE 4.0. Culture, workplace acceptance is not easy. We all know change is not easy. New systems, they come with resistance. Organizations have inertia, organizations have friction. We need to go through all of that piece and treat it like any other change management. Yeah, we can call it digitalization, we can call it digital transformation, but it's the transformation. Focus on that. Conversation is very important when you're making that change. Most of the times, most organizations I work with, this is what I hear. We have always done it this way. You could rephrase the same thing saying, up until now, we have done it this way. Now you're showing respect and experience to the past, but you're also opening the door for change. Instead of thinking spending, think investing. Instead of thinking how much money is at risk, think of how much you are investing to learn. If you think failure is not an option, then I'll tell you that failure to learn is actually not an option. Okay? In this transformation, there will be a lot of failures. There will be a lot of bloody things. Yeah, SpaceX doing so very well. And yesterday their rocket blew up again on landing. Elon Musk stands up and he says, mission was a success. I got everything I wanted out of this experiment. That's the spirit that drives people like Elon Musk to completely change industries. You know, in our lifetime, we haven't seen one guy come and disrupt 3 different industries. One thing for leaders here, it needs new leadership style. The hierarchical style will not work because the competition is unpredictable. Technology is changing fast and furious. And the communication needs are so real time that you're better off decentralizing and empowering your team to go take decisions, develop technologies, deploy, learn, adopt, pivot, fix it, learn as you go along, keep improving, because that's the way of we are going to now in the future. And also I would like to share that this journey is not an overnight thing. NDE 4.0 is not a switch that tomorrow morning the boss says, turn it on and you're Yesterday, last night, I slept. It was 3.0. This morning, it's 4.0. It's a journey. It could take multiple years, and we are all going to learn along the way. Okay, we have to deal with a lot of uncertainty, ambiguity. 2020 trained us to deal with uncertainty and ambiguity. And the way out of this is to go together, because there are just so many moving parts, so many technologies, so many stakeholders. Together is the only way. And Johannes and I are working very hard to bring people from all aspects of an NDE ecosystem, whether you're an asset owner, consumer, inspector, your university, regulatory agency, wherever you may be. Our objective is to take care of the asset, keep the consumer safe, keep the inspector safe, stay focused on our use cases, and everyone can then pull in. We've been having panel discussions. We're running journal special issues. There's so many committees all over. It's all about bringing the community together now to start accepting common practices. Next year, March, we're having a conference to bring people together. Please join. There are 2 journals which are already out with special issues on NDE. The next one is coming, for which call is still open. You can contribute to that. Please contribute. We're doing this as a, with the spirit of bringing community together. The global ambassadors that we started off in the US over here is now becoming a part of ICNDT. And we already have 17 countries participating in here. And we actually hope to bring certain solutions and guidance to everybody, particularly in terms of how do you create a roadmap and how do you derive items of importance for your roadmap, and how do you go down to the technologies and skills and knowledge that we need to make it happen. So all of this is coming next year in 2021. Stay tuned, engage with us. It's all of value. We have a YouTube channel. It's free. All of the stuff that we have been learning, we've been sharing continuously. Johannes brings out a new video every week just to make the community aware of what's going on. So that's what the process how is. It's all about treating it as a journey, willing to learn along the way and going together. It's not a solo part. We all have to kind of move together. A lot of details are in 4 books that have been released. It might sound like I'm advertising, but I make no money out of this. All the profit goes towards ocean cleanup. This is here for you to pick it up, and it is priced very low so that everybody can use it. And in the end, it is all about solving the problem, de-risking as we go through the 4th revolution. Our book on NDE 4 will be coming out soon. So whatever we presented today is going to be out published pretty quickly in a fairly extensive volume by next quarter. So in the end, I would, we will still have a few more couple of minutes for the questions. The question that I will throw at you is, if you want to lead this revolution, if you want to be a champion of NDE 4.0, you got to think innovation. You got to think of bringing a chief innovation officer in your organization. If you feel that you don't want to be the leader, you want to follow a leader and find a chief risk officer who will tell you which leader to follow and what elements to follow where, so that you actually do not go down the wrong path, which is a perfectly fine strategy. Choose to either be a leader or follow a leader. But if you just want to be an observer, then I would suggest that you hire a chief prayer officer, because this train is too fast and furious to catch up once we miss it. So with that, I would say thank you very much. I hope we have brought to you a perspective of why NDE 4 is important, what does it entail, and how to pursue that. With that, I will give it back to Shyam Sundar.
Thank you. Thank you to Dr. Ripi Singh and Dr. Johannes Vrana for an excellent journey. As I was mentioning even earlier, I think this is a topic which is quite new to the Indian audience, and that is why I wanted to make sure that we really have something to start the conference where the stage is set, where people understand the fundamentals, people understand the basics, and that way, there is enough, thoughts on people's mind about asking questions, about taking the right directions, and so on. So I don't think we could have asked for a better start to the technical sessions. Hearing it directly from both of you who spent so many years, kind of establishing this whole thing and taking it forward with your entire movement, with your international ambassadors, and with so many things which you showed. So clearly, I'm sure the audience has loved it, and hopefully will start thinking about it and see how and what they can adopt, or whatever they do. I see in the chat box that not too many questions. There's one which is not very relevant to this topic by Mr. Prasanta, so I would skip that. Mr. Prasanta, you can contact me offline for your question, and maybe I can give you some inputs. The other question was more on how I think you mentioned about more people to participate in the ISO. I think his question is about how do you participate in the ISO development?
You need to reach out to somebody at Bureau of Indian Standards, BIS office in Delhi. They are officially on the ISO 56000, but they have never sent anyone to participate in any of the meetings. I can understand up until last year may have been budget constraints, but now all the meetings are happening virtual. It costs nothing. They just need to send a name. BIS needs to send a name to the ISO office in France saying, this is our Indian delegate.
That answered your question, Mr. Niyant. I don't see any more questions here, but I'm very sure people have it on their mind. It's not being reflected here, but I think in the interest of time, what we will also do is, I think you talked about your YouTube channels and other sources of information. So I would certainly recommend to all the attendees who listen to this talk, please think over everything which we discussed in the last hour and 20 minutes. And I'm sure you can reach out to both Dr. Ripi Singh or to Dr. Johannes, and they'll be more than happy to answer your questions over an email, I'm sure, because they are driving this movement. So I'm very sure they want to take more and more people along. So they will be more than happy to answer your questions. With that,
absolutely.
I would.
And Johannes and I, what Johannes and I tend to do when people have questions, we make YouTube videos around those questions and put that out so that everybody gets an answer. Because typically a question that comes from one, there are 10 other people who have the same question but never asked for it. So we kind of spread answers all across, and that's what feeds the knowledge base through the YouTube channel.
Exactly. So I think there is enough resources. So I know this is a topic which people will have to think about, kind of introspect, and maybe those questions will come up. And then do not hesitate to reach out to either of them, and I'm sure they'll answer the question. So with that, I would profusely like to thank Dr. Ripi Singh and Dr. Johannes Vrana for having accepted our invitation and delivering this talk, which I thought was very, very useful and very, very important for the Indian audience, which I think has to take this much more seriously, in my opinion, and start doing something about it. I think we will see a lot of activity around that, having your talks during the pre-conference tutorials, and now for a much larger audience, as I believe there are more than, at the moment, 120 odd people who are watching this out of the total 600 plus delegates who are spread up across various halls. So thank you once again for having accepted our invitation and delivering an excellent talk, and we will certainly stay in touch. Thank you.